This electrical system presents several code violations and safety concerns. Firstly, concerning Article 400, this installation, intended for modular or closed construction type of building, is not a mobile home or recreational vehicle, so different rules apply. Secondly, Section 408.3c2 requires conductors to be protected from overcurrent in accordance with their ampacity. The number 4/3 wire, as described, is not adequately protected to its ampacity by the 60 amps fuses. This is a serious safety hazard, as an overload could cause the wiring to overheat and potentially start a fire. Section 250.146 states that a neutral conductor must be provided wherever line to neutral loads are connected. The existing system does not provide a neutral conductor for the 480-volt single-phase operation. This is a critical violation, as many 120-volt devices require a neutral conductor to operate safely and correctly. Without a neutral, these devices may not function correctly or could be damaged, or present a shock hazard. Article 450 governs transformers. The 15 kW transformer, as described, does not have a neutral terminal, which is required for single-phase operation. This omission is a significant issue, as a neutral is essential for providing a stable and safe voltage reference for the 120-volt circuit. Without a neutral, the voltage can fluctuate, potentially damaging equipment and creating a safety hazard. Article 110 requires conductors to be protected from physical damage. The rigid metal conduit THHN conductors and liquid-tight wiring, while suitable for many applications, are not suitable for use as mobile equipment wiring. Mobile equipment is subject to vibration, flexing, and physical stress, which can damage rigid wiring systems. Flexible wiring, such as cable, is designed to withstand these conditions. Section 110.11 mandates that electrical equipment must be installed and used in a manner that minimizes potential hazards to personnel. The discussed installation poses safety risks due to the lack of proper overcurrent protection and a neutral conductor. These deficiencies can lead to electrical shock, fire, and equipment damage. In addition, the intended use in an industrial chemical plant environment raises further concerns. Industrial chemical plants often contain hazardous materials and corrosive atmospheres that can damage electrical equipment. Standard electrical equipment may not be suitable for these environments and could pose a significant safety risk. Equipment used in such environments must be specifically designed and rated for the conditions present. The fact that the installation is temporary does not exempt it from meeting the requirements of the electrical code. All electrical installations, regardless of their duration, must be installed safely and in accordance with the applicable codes and standards. Temporary installations are often subject to the same requirements as permanent installations, with some exceptions for specific temporary uses. I recommend having the installation inspected by a qualified electrical inspector and certified as compliant with the electrical code. This inspection will identify any deficiencies and ensure that the installation meets the minimum safety requirements. The system must be re-engineered to provide adequate overcurrent protection, a neutral conductor, and proper wiring suitable for mobile equipment and industrial environments. This may involve replacing the existing wiring, installing a different transformer, and adding overcurrent protection devices. It's recommended to consult with a licensed electrician who is familiar with the specific requirements for industrial chemical plant environments. These environments often require specialized knowledge and equipment to ensure safety and compliance. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Together, grounding and bonding help to minimize the risk of electrical shock and fire. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. It is important to select overcurrent protection devices with the appropriate ampacity and interrupting rating for the circuit they are protecting. The neutral conductor provides a return path for current in single-phase circuits. It also helps to maintain a stable voltage level and reduce the risk of voltage fluctuations. The neutral conductor must be properly sized and grounded to ensure safe and reliable operation. Wiring methods must be selected based on the specific application and environment. Factors to consider include the voltage and current rating of the circuit, the ambient temperature, the presence of moisture or corrosive substances, and the potential for physical damage. Proper wiring methods help to ensure that the electrical system is safe, reliable, and long-lasting. Transformers are used to step up or step down voltage levels. They consist of 2 or more coils of wire wound around a common core. The ratio of the number of turns in the primary and secondary coils determines the voltage transformation ratio. Transformers are essential components of many electrical systems, allowing for efficient transmission and distribution of power. The electrical codes and standards are developed to ensure the safety of electrical installations. These codes and standards are based on years of experience and research and are constantly updated to reflect new technologies and best practices. Compliance with electrical codes and standards is essential for protecting people and property from electrical hazards. Qualified electrical inspectors play a vital role in ensuring the safety of electrical installations. These inspectors are trained to identify code violations and other safety hazards. They can also provide guidance on how to correct these problems. Having an electrical installation inspected by a qualified inspector is a good way to ensure that it meets the minimum safety requirements. Licensed electricians are trained and qualified to install and maintain electrical systems. They have the knowledge and experience to perform electrical work safely and in accordance with the electrical code. Hiring a licensed electrician is a good way to ensure that electrical work is done correctly and safely. Industrial chemical plants pose unique challenges for electrical installations. These plants often contain hazardous materials and corrosive atmospheres that can damage electrical equipment. Electrical equipment used in these environments must be specifically designed and rated for the conditions present. It is important to consult with a licensed electrician who is familiar with the specific requirements for industrial chemical plant environments. Temporary electrical installations are often used for construction sites, events, and other temporary purposes. These installations must be installed safely and in accordance with the electrical code. Temporary installations are often subject to the same requirements as permanent installations, with some exceptions for specific temporary uses. It is important to have temporary electrical installations inspected by a qualified electrical inspector to ensure that they meet the minimum safety requirements. Understanding the electrical code is essential for anyone who works with electrical systems. The electrical code is a complex and detailed set of rules that can be difficult to understand. However, there are many resources available to help people learn about the electrical code, including books, websites, and training courses. Knowing the electrical code is essential for ensuring the safety of electrical installations. Safe electrical practices are essential for protecting people and property from electrical hazards. These practices include using proper wiring methods, grounding and bonding electrical systems, using overcurrent protection devices, and avoiding contact with energized parts. Following safe electrical practices can help to minimize the risk of electrical shock, fire, and equipment damage. Electrical safety is a shared responsibility. Everyone who works with electrical systems has a responsibility to ensure that the work is done safely and in accordance with the electrical code. By following safe electrical practices and being aware of potential hazards, we can all help to prevent electrical accidents. Remember to always energize circuits before working on them. This is the most important safety precaution you can take. Use appropriate personal protective equipment, such as gloves and safety glasses. This will help to protect you from electrical shock and other injuries. Inspect electrical equipment regularly for damage. Replace any damaged equipment immediately. Never overload electrical circuits. This can cause the wiring to overheat and potentially start a fire. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, hire a qualified electrician. Always follow the manufacturer's instructions when installing or using electrical equipment. This will help to ensure that the equipment is used safely and correctly. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical repair should only be performed by qualified electricians. Be careful when working near water. Water is a good conductor of electricity, so it is important to avoid contact with water when working with electricity. Keep electrical equipment away from flammable materials. Flammable materials can easily ignite if they come into contact with electricity. Be aware of the location of overhead power lines. Overhead power lines can be dangerous, so it is important to avoid contact with them. If you are working near overhead power lines, call the power company to have them de-energized. Never use extension cords as permanent wiring. Extension cords are only intended for temporary use. If you need to extend a circuit, install a new outlet. Be careful when using power tools. Power tools can be dangerous if not used properly. Always follow the manufacturer's instructions when using power tools. Never leave electrical equipment unattended while it is turned on. This can be a fire hazard. If you are going to leave electrical equipment unattended, turn it off and unplug it. Be aware of the signs of electrical problems. These signs include flickering lights, sparking outlets, and burning smells. If you notice any of these signs, call a qualified electrician immediately. Educate yourself about electrical safety. The more you know about electrical safety, the safer you will be. There are many resources available to help you learn about electrical safety, including books, websites, and training courses. By following these safety tips, you can help to prevent electrical accidents and keep yourself and others safe. Remember, electrical safety is everyone's responsibility. The analysis of this electrical system reveals multiple and significant safety violations that must be addressed immediately.